Tech Talk Tuesday, number 101, y'all. One, 0, 1. Y'all, this is 3 Tech Talk Tuesdays. This is 3 of them away from 2 years. That's crazy, isn't it, y'all? John, Alex, John, Charlie. Hey, Charlie. I'm thankful for you, Charlie. Matt, Alex, Alan, Esther. Cool. Glad to see you guys clicking on. Got some stuff to tell you and share. Also, I want to do a little tour of my new man cave that I've got. Jackie and I have been working on, and some friends here up in the Tennessee area that have helped me get this place in shape. Hey, Mike, brother Mike, Sean, Charlie, John. Y'all sign in now. Come on. I got some stuff to share with you. I'm going to let everybody catch up right quick. See a few of you signing in. Yep, this is the finals. Superbike Mike and me, NHRA at the Texas Motorplex in 1987. Yep, I was a young man. This was right after I had wooden wheels on my bike. Mike and I had Cosman components on our bike. Both had the big tires on the back. We had the Goodyear Eagle. It's a car tire at the time. Mine was a little bigger. Mine was a Camaro tire. I guess I've got a little bit connection problem. Maybe it'll tune up here in a minute, I hope. But I want to tell you a quick story. Hey, Jackie. Hey. Well, I don't know if I've got a connection problem or not. If I do, I'm sad. Y'all can let me know. Alex, Tanner, Brian. Good to see you guys. All right, they're catching up. A few more names coming in. Tech Talk Tuesday, number 101. Okay, so what I'm going to do is I'm going to talk to you a little bit about, you know what I'll do? I'll give you a quick tour first. How about that? Maybe this will help with the connection. I don't know. Move around. Maybe I can lock in. Hey, Mike, Alan, Greg. Connection is fine. Thank you, Enos. All right, I'm going to turn this up and move a little bit so I can kind of show you around a little bit. We'll try not to shake or move too fast. There's a little area where in the bike lift room, I hadn't really decided what this room is called yet, but I've got a bike lift. 2 of them. I got one for each bike. Hey, Terry, Chuck. Got some Wallies don't have shelves yet, but I got shelves coming. There's another one, few up there. There's a couple of ones. I got the separating some of them for fun, like the Las Vegas ones are together and the English Town ones are together. And these right now are the ones, 5 of the ones from India. I think we have 7 of those. I got to dig them up. Over here, I know I've showed you this before, but I'm going to do another little bit. This is a few of the championship ones. Hey, Chad. Hey, Daryl. And this is Buck. Buck is hanging out on the floor. He actually runs. And here is Black Beauty, the Road Glide Special. But I wanted to show you a little bit on Buck. This is a 126 that we bored out and made it bigger than a 126. I think it's 129 now, but it's got 143 cylinders on it. And it came with a little baby tire, and we put a 17 on the back so we could put a 160 on the back. This is only a 160. There they are. I'll back up here and give you another view of the man cave. Back down here are some offices and a meeting room that we have not finished yet, but we're working on it. And then I'll put my 4-post lift in and got the El Camino in here. And it's hanging out right now. Look at this cool supported this ceiling here. This building has 44 of those concrete beams, 44 of them this way and I think they're about 40 feet this way. So and it's a double block wall building, so I think it'll stand up. Been around for a long time. But anyway, here's the little backdrop of the shop from over by the El Camino. Now I'm going to move on to the subject of the day, which is, it seems a little monotonous to talk about ring seal, but I got to tell you guys, after lots and lots of work, I'm going to expand on ring seal a little bit, because it's the most important thing we do in our engine. Seal is. I mean, if you don't have seal, then you don't have horsepower or reliability. But first, I want to tell you this really quick story about Superbike Mike Keat. He was a pro stock champion back in the day, and he was one of the first showmen. He and his wife Kathy would dress up with these really cool red and white suits, and they had little dogs that had little vest on them that said Superbike Mike, and his name was Superbike Mike, and he was from Fort Lauderdale, Miami area, and he would build really fast motorcycles. And when I started in pro stock, I wanted to outrun him really bad, so he was a great guy to try and go fast. Even in 1979, I bought a motorcycle, a street bike, kind of a pro stock bike, from a fella named Bobby Van, and it had a Superbike Mike head on it, and it was fast. It made a lot of power, and I didn't know anything at the time, so Mike told me that it had little valves in it and really nice ports, and it was really efficient, and I put it on my bike, and I ran good with it. Then we started our own company, Star Racing, in 1979, shortly thereafter, and this is one of our GS 1150 4 valves that I ran before John Myers. We got John Myers, thank the good Lord, may he rest in peace, but we got the late great John Myers to drive for us in 1989, and this is 2 years prior to, and this is my first win NHRA Pro Stock on a Pro Stock motorcycle. Now, this race, the Chief Nationals, in 1987, I'm going to try and say this right, was a very unique race. It was the first time Billy Meyer let the motorcycles run at the Texas Motorplex. It's the first time NHRA brought us in to race, and we had no sponsor. Castrol was our sponsor, but they were like, we got Castrol hats, and Mickey Schultz was a guy that ran the Castrol program, marketing program for NHRA, and he was in Winter Circle with us. A couple things interesting. Terry Vance qualified number 1 at this race at a 799. This race right here was the first time a normally aspirated pro stock motorcycle went in the sevens. Terry qualified number 1, 799. Superbike Mike qualified at 804, and I qualified with a 8010. I was, I think, probably number 7 or 8 qualifier, maybe number 6. But I was cutting the light better than everybody else, because I don't know what they were doing, but they were trying to get the clutch slip right, because in these days we slipped our clutch. We would take off like street bikes, and we'd let clutch out nice and easy, and I would get the clutch loaded up and I'd leave first. So they were cutting 500 lights, 0.500, 0.505, and I was going 0.480s. Still have the clip from the National Dragster, and so I was able to go quicker I was able to go to the finish line first without going the quickest ET, but I ended up winning. I have the Wally here. It was a great day. It was my first NHRA Pro Stock win, and after a long time, we ended up collecting them, and I'll tell you more about that in a minute and why. Superbike Mike, in the final, he went quicker than me in the semis, and he got lane choice, but I talked to him about it probably 100 times since, and he said he was going to win if his oil pump gear hadn't broken. Well, I understand. I'm sorry, Mike, but it was great. Thank you for sacrificing your oil pump gear for me to get my first NHRA Pro Stock Wally. After all these years of practicing and racing and going through all the great champions that we've had a chance to work with over the years, we ended up collecting 80-something of these. And all of these were Pro Stock except for one funny bike Wally that I got back in '84. But what I didn't get this up here to brag on it. What I wanted to tell you is what we learned with each and every one of these. Oh, there was so many things we learned. We could write a book about everything we learned, because these also represent how many of them we lost. We went to 155 final rounds, and we got 82 wins. out of 300 and something races. So we had a really good batting average, but I wanted to share with you about ring seal. And I'll start off by saying, what is big bore to you? Well, this is a little 4-valve piston, a little pro stock motorcycle piston, 2-valve, and this was our 5 1/8 S&S 5.125 bore, and then this is the two of them together. So both of them are big bore. This is big bore for a Suzuki, and this is big bore for a V-twin. This piston's over 5 inches, and this one's only 3.5 inches. But I wanted to share with you how we learned about this stuff. All right. What is big bore to you? Well, big bore, flow versus valve area. How to determine bore versus stroke for more power. Biggest bore, then do the stroke, then do the rod length, and then torque versus how much torque do we have? No idea. We never worried about that in our pro stock stuff. That ended up being a result, not a reason. Bore stroke, okay, stroke versus airflow. Bore limits include bore-to-bore center-to-center measurements. That means when you have a V8, the cylinder, the pro stockers have to run a 4/900 bore space. That means like 2, 4, 6, and 8 on one side of a V8. And the biggest you could bore it would be whatever's right here, because you could put a big bore here, and you could put a big bore here. But the bore-to-bore center line is the limit. And then of course, head bolts. Some of the V8s have to share, some of the cylinders have to share head bolts. And on the big block Chevys, over the years, they ended up adding one in the valley to make a better clamp. And that's what we're going to talk about, the sealing. Okay. Let's see if I can get this a little bit closer for you, maybe, so you can read it better. There you go. Styles and sizes. The weight of the ring matters, and the G-force as it goes to the top and the bottom. Surface finish. The RA is the roughness average. The RPK is the reduced peak height, and the core RK is the core roughness, and the RVK is the valley depth. Now, I'm going to show you what that looks like when you... I don't know how to do that. We'll move over here as I fumble about. When you hone the cylinder, if you blow it up really big, you end up with a really jagged finish. And the RPK is when you come in with a finer stone and you cut these peaks away. And the RVK is how deep the rough stones go. And the RVK is what retains this oil that we need to lubricate the pistons. I've been over that before, and I'm gonna slide over it right quick here. Rings, they matter. The conformability of the rings. Now, there are rings out there that are so stout that they don't conform well to the cylinders. I know you're going to get some questions on this. All right, the purpose of a ring. Please forgive me for shaking. I'm just trying to get this camera where I can get all of this in. Seal combustion gases from the oil pan. To use pressure on top of the piston and above the rings. Y'all make fun of me. It's okay, I can take it. The only people that don't get made fun of are the ones that sit on the couch and sit on their hands and don't do anything. The purpose of the piston ring is to seal combustion gases from the oil pan, to use pressure on top of the piston above the rings to push down on the piston to rotate the crank. To seal the oil from the combustion chamber. I'm going to tell you something, y'all. In a gasoline-powered, normally aspirated turbo nitrous supercharged, we do not want oil in the combustion chamber, because oil is a great lubrication, but it wrecks octane and it makes detonation if it's in the burn area. To burn clean and make power. Also, a very important thing that we lose sight of a lot is the piston. The only way we can cool the piston is for the heat in the piston to go through the piston rings into the cylinder wall. And the cylinder wall, around the piston, the cylinder wall has the water jackets or the air-cooled fins that cool the cylinder. Proper cylinder preparation, that means bore geometry and proper surface finish based on the application. So everybody has a different one. Everybody has a different idea of what they want for cylinder finish. In my book, it needs to be really smooth, but it needs to have deep grooves to hold oil, and it also needs to be really round at a dynamic operation, not necessarily just sitting static in the shop. It needs to be really straight while it's running at peak speed and peak temperature. It needs to be really round while it's running at peak speed and peak temperature. The piston has to be designed correct for the application, and that's not just to fit the head, just to fit the cylinder, just to fit the bore and stroke and the rod length and the wrist pin, but also to hold the rings correctly. If the piston is not designed to support the rings, then the rings can't do their job. And the oil has to be correct for the application. That's another whole story. If any of you noticed this little deal down here, this is a presentation I did at the ATEC conference AETC conference about 5 years ago, and I thought it had some good information, and I thought I would just share it with you guys right quick. The leak path. When you're checking your leak down on your engine, when you have say a 20 gap on the top ring or a 25 thou gap, and you put the leak down pressure in the cylinder, it's going to blow right through this gap, and it's going to tell you leak down. Maybe 5%, maybe 10%. The bigger this gap is, the more it'll show. One thing that we do not realize, or we fail to remember, is how long this ring is. If you take a 5-inch bore and straighten that piece of wire out, that ring is a wire, and you straighten it out, it's 15 inches long, and it grows so many thousandths per inch. So when this is running at peak temperature, at peak speed, this ring gets longer, this wire gets longer, and it closes this gap up. So in reality, when you're done racing, you should be able to take your engine apart and look very carefully with a light and a magnifying glass, and you may see where these two ends touched each other when they were at peak temperature and peak operation. And if they touch each other without hitting, like they just show a little light kiss, that's when it's perfect, and then it's running at zero gap. Now, in order to fix leak down, where an engine builder has to show his customer that I do better than everybody else and I have no leak. My engines don't leak. They can put a gapless ring in, which will show zero leak down when the engine's cold or warm or whatever. But that's not necessary, in my opinion, for us to try to get more power. Now, Total Seal sells gapless rings, and they do really, really good with them. And there are people out there that go really, really fast with gapless rings. So I'm not telling you don't run gapless rings. I'm just telling you that I don't. The second leak path is around the ring groove. This is where the piston and the ring do not match. Yes, I bought the best piston I could get. Yes, I bought the best ring I could get, but they don't go together. Just because it's the best piston and it's the best ring does not mean it fits. This should be the most matched up combination you can come up with. And then when you get this crappy ring and a crappy piston, you're going to have a really bad leak right by here. And that happens for several reasons. One reason it happens is because this piston's going up and down 100 times a second, and this ring is trying its best to follow. And you can see in this diagram it has some clearance. If this clearance is excessive, this ring will sit in here, and it will try to catch the piston and come to a stop. The piston will go down, and the ring will keep going. Then when the piston goes up, the ring keeps going, and when the piston stops at the top, the ring keeps going. So every time you get the momentum to separate these two parts, you're going to get bad ring seal. It's going to blow right past the cylinder wall into the pan. The story I had that I wanted to share with you was when S&S started the S&S 160 Pro Stock project that we had going back in 2003 and 2004, which is the one running in NHRA now. What I wanted to share with you about that story is the guys at S&S did a great job coming up with a big enough bore and the right stroke to get the 160 cubic inch rule that NHRA recommended. So there were no rings available. So they had to go get aircraft rings or air compressor rings that were a cast iron first and second ring and an unbelievably tight Hastings style 3-piece oil ring it was a giant ring. It was giant in axial height. It might have been 100 thou tall, and it might have been 200 wide in axial, width, and the tension on it was really, really big. So, but it was also a cast iron, which can't handle the heat. Remember, an aircraft engine might be, a good one's 3,000 RPM. Air compressor might be 1,500 RPM. So if you use a 1,500 RPM or a 3,000 RPM ring that's designed to be everything you need it to be at 3,000 RPM and that piston speed, remember, when you get it up to 10,000 RPM, it may lose tension because of the heat. It may be so heavy that the piston cannot control it. I don't know if you can see my hand, but the inertia, piston comes up and stops and the ring keeps going. Loose seal. Piston goes back down, stops, the ring goes down. Loose seal. So the ring is trying to catch the piston every time it goes up and down. So the weight of the piston ring matters. The other thing I want to tell you, the great bravo for the guys at S&S is they made this engine run, y'all. They got this thing on the dyno with the only rings a man could come up with, and they had to get them cut. They had to cut rings on their lathe. They had to order special rings from Total Seal and from Hastings and everybody that would listen to them to get a 5.125 bore ring. And I'm telling you guys, this was 16, 17 years ago when this was going on. And they got this engine to make 250 horsepower. And there weren't any really good ways to measure the blow by in their lab at the time. And if you were running 8,000, 9,000 RPM with an air compressor ring at 5 and an 8, the ring was not sealed up. The bores were not sealed up. So 250 horsepower out of 2 cylinders, I think that's what, if I did math good, that would be 250 is 175, 125, 125, 2P, 125. 125 per hole. Now, just by getting pistons made to fit a nice set of rings, getting a set of nice rings made just to fit that piston, just to fit that bore, which costs a lot of money because you had to start from scratch to get rings made this big. It was worth 60 horsepower. It was worth 30 horsepower a hole. So if that was a V8, what's that? 240 horsepower gain with ring seal. Now, what was going on? Where was the 30 horsepower per cylinder going? The compression or the cylinder pressure in the cylinder was going, and it would send the piston down, but a large majority of it was going past the piston into the bottom end, and there was not an oil pump that could handle that because it's a dry sump engine. The pressure going in the bottom end was giving them a hard time because the first thing they tried to do was use an old XL Sportster, a billet, really big billet Sportster oil pump to try and get supply to the bearings and to evacuate the oil out of the sump back into the tank. So it had one oil pump that would put the oil in, and then it would take it on the return and try and pull it, scavenge it back into the tank. I remember when we first started running this thing in 2003, 2004, we put an electric pump on, an electric oil pump to get enough oil to it. Then we put an electric vacuum pump to try to get the oil to scavenge the oil out of the sump back. We didn't get anything to work. Finally, S&S came up with the Daily Engineering. They make some really nice pumps. And this was a little baby oil pump that had 2 stages. It had one stage, a little narrow stage for a -6 hose to supply the bearings and a -12 hose to scavenge the oil back out of the sump into the tank. The thing that made it work, finally, when we got the ratio right, we were running that oil pump at 1.2, no, we were running it 20% faster than the crankshaft. I think that's right. We were running the oil pump 11,000 RPM, and we were running the crankshaft like 9,500. And that was finally able to get enough pressure to the bearings to make the bearings look right and to get enough scavenge to keep the sump empty enough to keep enough oil in the tank. Anyway, that was some fun days learning that stuff, but what it did is it put us right back to the Flintstone level of trying to come up with these to get, yes, great engine design, great on the dyno, getting it in the machine and get it to go up and down the racetrack successfully was our job that we were hired to do, and ended up being some great wins for us. Sold a lot of them. I think S&S made 100 of those engines now, maybe more. I know we sold 30-something of the complete V-twin 160 cubic inch. It was 3.8 stroke, 5.1 bore, had the big 2.75, 2.8 intake valves and the 2.1 exhaust valves. And it was a great learning experience for us. Now, last thing I want to say about this, you guys, This is not about Harley Davidsons. This is not about car engines, pro stock engines. This is about engines. All of these things, what we learned in the fast lane, 1 or 2 cylinders at a time, was what to do to a V8, what to do to a V12, what to do to a 4-cylinder. And some of these rules, not rules, but some of these ideas and some of these methods still apply today. And I wanted to share that stuff with you guys so you could kind of see the travels and the hill we had to climb to go. Ended up at 400 horsepower. Started off at 250. They ended up selling them at 300 horse, which was really great. I think they sold, like I said, when they were selling them 300 horse, then they started selling with 330, started selling with 340, then they started selling with 350 horsepower. And I think the last iteration that you could buy from S&S was about 350 horsepower with this 160 V-twin. And the guys that are going fast right now, you can tell by their ET and mile an hour. Matt Smith and those guys, some of them are running right at 400 horsepower now. And it might be 405, might be 395, and they're turning them 10.5 to 11,000 RPM now. But they have really nice rings. They don't weigh a lot. They have a real small radial width. They have a real small axial height, and they don't weigh much, so they can keep up with the piston. That's about the time I have tonight. Sorry, I kicked the stand. I have on my black cat socks today. And I'm thankful for you guys to check in on Tech Talk 101. Tune in next Tuesday for Tech Talk number 102. And we're almost to 2 years. Every Tuesday night, 6 o'clock Eastern. May God bless y'all. Thank y'all for watching. Hey, Jackie's going to make a recording out of this, and she'll post it on YouTube. It'll be Ring Seal 101. Just happens to be Tech Talk 101. If you have questions, email me, george@starracing.com, or you can message me right here. Thank y'all for all of the attention and watching. God bless y'all. Love y'all. Bye. Have a good night.